known as the law signal, reached an intensity up to 30 times higher than the usual signals and had a duration of 72 seconds. Its name comes from the note written at that moment by the person who discovered it, Jerry R. Eman, collaborator at SETI project, a project for the search for extraterrestrial intelligence founded by NASA in 1960. The law signal is, among all the strange signals received up to now, the one that has the greatest likelihood of having been emitted by intelligent extraterrestrial beings, despite its origin still being uncertain to this day. In a vast universe, 40 billion years old and containing 500 billion galaxies, science is convinced that there must exist, or must have existed, extraterrestrial intelligence. In this vastness, it would seem that there should be fullness of life out there. With this conviction, human beings have searched for it and still search for it incessantly. State-of-the-art radio telescopes track the sky day and night, year after year, in search of any sign of extraterrestrial intelligent life. Nevertheless, in 2009, everything changed. That year, NASA launched the Kepler satellite into space. And thanks to it, we have found thousands of Earth-like planets where conditions for life might be possible. This has meant, undoubtedly, a total revolution in the search for extraterrestrial intelligent life. Given the important advances in astrophysics, some scientists believe that there is a chance of finding extraterrestrial intelligence in the next decades. Seth Shostak, astronomer and director of SETI, Search for Extraterrestrial Intelligence, declared before the House Science Committee of the American Congress that in a couple of decades, we will have found evidence of its existence.
The chances of finding it, I think, are good, and if that happens, it'll happen in the next 20 years, depending on the financing.
A first contact could be close. The question is, do we really want them to find us? What will these forms of life be like? What will their aims be? Is anybody out there? Given the millions of billions of Earth-like planets, life elsewhere in the universe, without a doubt, does exist. In the vastness of the universe, we are not alone. Albert Einstein. 4.5 billion years ago, in the vastness of the universe, the Earth, our home, was formed. From the birth of the universe, it took 14 billion years for human beings to arise, just 6 million years ago. To give us an idea of the time which has passed until our first steps, Carl Sagan made a time comparison in which, if the age of the universe was a year, the Big Bang would have occurred on January 1st. On September 8th, the Sun would have formed. On September 11th, the Earth would have formed, and we would have been born the last day of the year, December 31st, at 11:39. How many things must have happened in other places during the same time?
Today, when we take a look at what we know about the universe and what we know about the origins of life on this planet, it leads us to think that the same things that happened here might well have happened elsewhere. And so life beyond this planet is quite plausible in terms of the science that we know today.
We see the organic building blocks that are essential to life on Earth. And so the raw stuff that's necessary for life is out there. The places that life could live is out there. The big question is, do they come together and form a second Genesis?
We take up a tiny place in the immensity of the universe. The Milky Way, the galaxy we live in, might have around 100 billion stars. Among them, our sun. In total, it measures around 100,000 light years in diameter.
Maybe there are a million, maybe there are a billion, maybe there are 100 billion planets in the Milky Way galaxy that could support life, the kind of planets that earthly life could survive on. How many of them have cooked up their own life?
Here, from one end of the Milky Way, we, an intelligent civilization, wonder if it's possible that we are alone in all of this vastness.
There's just a lot of real estate, a lot of room for life in space. We've now learned that planets are as common as cheap hotels. They're all over the place. There are 1 trillion, that's a million planets just in our own galaxy. If there is no life on any of them, then Earth is a miracle. A miracle. And I'll tell you this, for scientists, believing in miracles is usually not a good strategy.
When we think about how vast the universe is, it would be incredible if there's no other life out there. There are hundreds of billions of stars in our galaxy alone, and there are billions of galaxies in the universe. If life appears on only a minuscule fraction of those planets, then life is prevalent throughout the universe.
That's why human beings, in their enthusiasm for knowledge and exploration, have started the search for intelligent life, with the hope of, sooner or later, finding it, or being found by it.
Oiknis poteste hairete,
Asa adra asa.
eirenikos prosfilos elelisamen filoi.
Paz e felicidade a todos. تحياتنا للأصدقاء في النجوم يا ليت يجمعنا السماء.
Koloranon, borgăcățnăvin, evechim amazăciuneren ansin, bocciunner.
પૃથ્વી ઉપર વસનાર એક માનવ તરફથી બ્રહ્માંડના अन्य અવકાશમાં વસનારાઓને હાર્દિક અભિનંદન. આ સંદેશો મળે વળતો સંદેશો મોકલાવશો.
This search can be done in two ways: tracking signals that may come from any extraterrestrial civilization, or sending our own messages into space, which may be received by one of those civilizations someday.
Active SETI, also sometimes called METI, messaging extraterrestrial intelligence, reverses the roles. Instead of passively listening for a signal from another civilization, we send intentional, powerful signals to nearby stars in the hope of getting a reply back.
With this goal, in 1977, the most elaborate and comprehensive message to date, The Sounds of the Earth, was launched into space. A moving introductory message including everything that human beings consider that an extraterrestrial civilization should know about our species. It was included on a golden record on each of the Voyager interstellar space probes launched that same year from Cape Canaveral.
It was a golden record. On one side, there were encoded music from around the world, greetings in 55 languages, a 12-minute sound montage of the evolution of life on Earth. And on the other side, there were pictures, over 100 pictures describing some basic mathematical principles in the diversity of life and culture on Earth.
The content of the recording was carefully chosen by NASA and a committee chaired by astronomer and author Carl Sagan. The audio section has a salutation in English from the UN General Secretary and short messages in 55 languages, welcoming and wishing peace to all forms of life.
Witajcie.
toate zahiato.
Asha Adra Asa.
Via Numelisa, Mare.
Hello from the children of planet Earth.
But that one was not the only message sent.
There have been a few symbolic transmissions to other worlds. The most famous transmission to another civilization happened in 1974 from the world's most powerful radio telescope in Arecibo, Puerto Rico. It was a very simple message. It took 3 minutes to send, and it provides a mathematical and scientific overview of life on Earth.
Nevertheless, the search for extraterrestrial life is not founded just on the sending of messages in the hope of a response someday, but on the development of a search for signals that may indicate the existence of that intelligent life.
SETI, as a scientific exploration, actually got its start within NASA, in the life sciences portion of NASA. People were interested in the question of life beyond the Earth, and this program developed within NASA. It launched actually in 1992. It was called the High Resolution Microwave Survey. In 1993, Senator Bryan from Nevada terminated NASA's funding for SETI, and he terminated with a vengeance so that NASA was unable to recover and come back the next year with another SETI program. So at that point, because we had already formed a nonprofit institute called the SETI Institute to help NASA stretch its funds as it did this SETI work, in 1993 we said, okay, we've got a nonprofit. We're just going to go out and raise money to do this privately.
The SETI Institute is nowadays the main world institution devoted to the search for extraterrestrial intelligence.
It's a project called SETI, the Search for Extraterrestrial Intelligence.
This search is based on the use of radio telescopes. Radio telescopes receive radio waves. As we can't go to space aboard spacecrafts to find that intelligent life, what we look for are radio signals.
What we're looking for is a signal that's at one spot on the radio dial. Just like when you're listening to the radio in your car. You know, you tune across the dial, you hear static everywhere, and then at one spot you're, and there's a station. Okay, that's the signal that's produced by a transmitter somewhere. It's not natural static. It's not like a quasar or a pulsar or galaxies or hot gas, cold gas. All those things in space make radio noise, but it's all over the dial. So we look for signals that are at one spot on the dial, and of course the source of the signal has to be up in the sky. Those are the kinds of criteria we use to know that even if we don't know what it means, we at least know they're there. They're on the air.
One of the biggest SETI projects, started in 2007, is the Allen Telescope Array, which seeks to install 350 antennas to receive possible messages from outer space.
We designed this. We went to Paul Allen and asked him to fund it. Then he was generous to fund the first phase of construction of what we now call the Allen Telescope Array. It's in Northern California near Mount Lassen. The Allen Telescope Array has 42 telescopes. Someday we hope to grow it to 350.
The Allen Project will become the most powerful instrument in the search for signals from other civilizations in our galaxy. Since it was launched after just a few months in operation, it has been able to analyze the same amount of area of the universe as in the last 45 years of SETI's existence. Another of SETI's most famous innovative projects is SETI at Home. It was started in 1999 by astronomers at the University of California in Berkeley, and it uses an army of millions of amateur internet users. From home, anyone can be part of this enthralling pursuit. The screensaver analyzes some of the data that comes from the Arecibo radio telescope in Puerto Rico. Up to now, more than 5 million people from all over the world have participated and are processing all of the info captured by the Arecibo radio telescope. The SETI at Home project has grown so quickly that it is the biggest ever of its kind. Both projects, Allen Telescope Array and SETI at home have been a huge advance in the search for intelligent life, giving hope for discoveries in the near future. But undoubtedly, what has radically revolutionized and pushed the search for extraterrestrial intelligent life is the Kepler mission, which is focused on the search for potentially inhabitable planets. It was launched by NASA on March 6, 2009, and orbits the Sun looking for extrasolar Earth-like planets where life may be possible.
Kepler, which is a space-based telescope that was launched about 5 years ago, is on the hunt for planets. Kepler has found literally thousands of planets or planetary candidates. It's a planet-finding machine.
The Kepler spacecraft has been a game changer in the search for other intelligence. Kepler now can tell us which stars have planets around them and which of those stars are Earth-like. That means we now know where we can point our telescopes to look for a twin of Earth.
In 2011, for the first time ever, Kepler provided scientists with a census of the Milky Way. For the first time ever, we can calculate how many stars in the Milky Way could have a planet like ours. Around 1 billion.
So one of the big triumphs of astronomy in the last 2 decades is to show the majority of stars have planets. There are planets all over the place. There are more planets than stars.
According to the data, in the near future, millions of inhabitable planets may be found just in our galaxy.
What Kepler has shown is that maybe 1 in 5 stars has a planet which could have liquid oceans, a bit of an atmosphere. In other words, the kind of place where you might want to build yourself a house, right? So 1 in 5 means that just in our galaxy, there are tens of thousands of millions of cousins of the Earth. That's a lot of real estate.
This data is crucial to answering the question of whether we are alone in the universe and helping us to resolve some unknowns of one of the most famous equations in astrophysics, the Drake equation, which is now of major interest.
The Drake equation is a way to grapple with all of the issues most central to determining how many civilizations are there out there in our galaxy trying to make contact. The Drake equation looks at 7 independent factors and tries to put a number on each of them.
So you multiply all this up, and you come up with a number that we call N, the number of potentially communicative civilizations in the Milky Way. Our star is the rate at which stars have been born in the Milky Way galaxy over the last few billion years. So it's a number that is stars per year. Our galaxy is 10 billion years old, and early in its history, stars formed at a different rate. All of the F factors are fractions. Each one must be less than or equal to 1. F sub p is the fraction of stars that have planets. N sub e is the average number of habitable planets in any planetary system. F sub L is the fraction of planets on which life actually begins, and F sub I is the fraction of all those life forms that develop intelligence. F sub C is the fraction of intelligent life that develops a civilization that decides to use some sort of transmitting technology. And finally, L, the longevity factor. On average, how many years do those transmitters continue to operate?
That is perhaps the most elusive term of the Drake equation. As we look into our own future, we wonder, will we survive as a technologically adolescent civilization? Will we last long enough to make contact? That is the big unknown.
The Drake equation includes a series of terms whose value we can't know exactly.
It's just a fantastic framework with which we can organize our ignorance, because you can't solve the equation. There are no right answers to that equation, not yet.
As we shift into the more biological and cultural terms of the Drake equation, we move into areas where we're uncertain.
But during the last few years, we've seen how exoplanets have arisen in front of our eyes, thanks mainly to the Kepler space satellite.
When Frank Drake first wrote down the Drake equation back in 1961, he put his own personal estimates into each of those vectors and came up with a number, his estimate, which was 10,000. So within the Milky Way galaxy of 100 billion stars, he thought 10,000 of those stars might host technological civilizations.
What do we know now that we didn't know in 1961? Well, we know one or two of those terms a little bit better. And they kind of agree with the optimistic estimates that were made 50, 60 years ago.
There are other estimates that are extremely pessimistic. There's only one, and it's us. Carl Sagan had a number that was more optimistic. He said probably 1 million was his guess. We think we know that our star and N-Sub-E are both numbers that are closer to 10 than, say, to 1. And all the F factors are less than 1. Some of them may be much less than 1. But of all these unknowns, the biggest unknown is L. So perhaps the most useful version of the Drake equation is simply to say that N is approximately equal to L. The information in this equation is very clear. Unless L is large, N will be small.
And these are estimates just for our galaxy. But we don't have estimates just for our galaxy, but for the visible universe. This fact multiplies the chances for the existence of extraterrestrial intelligence. The Hubble Space Telescope has given us an approximate calculation of the total number of galaxies in the viable universe. 100 billion. So we can calculate the number of Earth-like planets in the visible universe. 1 trillion Earth-like planets. The universe is 14 billion years old, so there has been time enough for intelligent empires to arise and possibly fall. It would be miraculous if no other advanced civilization anywhere had ever existed. It's just a matter of time until we find them. Radio telescope technology is becoming more and more advanced, and some scientists believe that the first evidence will be found in the next decades.
So far, we've looked at a little over 10,000 stars very carefully with the Allen Telescope Array. In the next couple of decades, that'll be 1 million stars. And by the time you've looked at 1 million stars, that's a reasonable number to find intelligent life, if it's really out there.
In fact, people like Craig Venter and Daniel Cohen have said 20th century was a century of physics. 21st century is going to be the century of biology. But my colleagues and astrobiologists and young scientists are saying, yes, the century of biology on Earth and beyond. This coming century, this 21st century, could well provide us with evidence of life beyond Earth and a biochemistry that's different from the only one we know.
The chance of an imminent discovery brings with it a controversial question. What will the first contact be like? What could human beings say to another intelligent species? What introductory message can we compose about human beings, that species that inhabits one of the edges of the universe, and who have developed enough to wonder if there is anyone else out there, or to try to find them?
There should be a deliberative process to think about how we want to present ourselves to other worlds.
And that is a dynamic conversation that we're having now in the science community. Should we transmit? If we do, who should speak for Earth? What should they say? In what language? How?
It's not a simple task to ponder a first introduction to an extraterrestrial intelligence, and the even more complicated question of how to compose that message to make it understood.
How we would say something meaningful to another civilization. It is going to be one of the most tremendous intellectual challenges humankind has ever faced.
Composing a message that can be understood by aliens will be extremely difficult, and conversation may be impossible.
In in order to make contact with another civilization and truly understand them, we have to find a language that any scientist who is engaged in SETI anywhere in the galaxy will understand.
This is what's called active SETI, or METI, messaging to extraterrestrial intelligence.
If you can build a radio transmitter anywhere in the galaxy, you have to know that 2 + 2 = 4. And so it's basic mathematical principles like that that we use as the foundation for a language to communicate with extraterrestrials.
In terms of the message content, how it should be sent, what it should say, what would we say about ourselves, and what are efficient encoding schemes, and how do we provide a tutorial so that they can figure out what the scheme is.
My suggestion is to send the internet, right? Send so much information that they can look through it and find pictures, videos, sounds, text, of course, and they'll be able to understand it. Sort of like the hieroglyphics.
Several messages have already been sent to space, and we hope to receive an answer someday. The first sent message was attached to the Pioneer 10 space probe, launched by NASA from Cape Canaveral on March 2nd, 1972. A golden anodized aluminum plate designed by astronomers Carl Sagan and Francis Drake was affixed to the probe. It was a kind of an interstellar message in a bottle. On it, drawings of 2 human figures appear, one feminine and one masculine, with the image of the spacecraft behind them to show the proportion of the human silhouettes. Our address in the universe was also included, as well as a scheme of our solar system. Another similar plate was affixed to the Pioneer 11. The next message, sent in 1974, was designed by the Dr. Frank Drake and transmitted by the Arecibo radio telescope in Puerto Rico. This message is generally known as the Arecibo message.
It was a very simple message. It took 3 minutes to send, and it provides a mathematical and scientific overview of life on Earth. It starts with a description of our numbering system in a binary code, numbers from 1 to 10, and then using those numbers, a description of chemical elements that are essential to life on Earth. And once we can talk about those chemicals, we can talk about the way they combine into molecules, including DNA, the core of our genetic material here on Earth. The Arecibo message also gave a description of our solar system, the population of our Earth, even a diagram of the telescope that was used to transmit the message.
1977 saw the launch of the Sounds of the Earth, the most elaborate and comprehensive message to date. Recorded on golden records, they were affixed to each other on the Voyager spacecrafts. Besides salutations in 55 languages, they included an audio section devoted to the sounds of the Earth. Volcanoes, lightning, wind, laughter, and the message in Latin, per aspera ad astra, through hardship to the stars, in Morse code. Also included were eclectic selections of music from different cultures. The Brandenburg Concerto No. 2 by Bach. The Magic Flute by Mozart. The Melancholy Blues by Louis Armstrong. Beethoven's Fifth Symphony. As well as traditional music from different cultures. In addition to the audio, 116 photographs were sent showing different forms of life on the Earth and human society. Mathematics definitions, the structure of DNA, a diagram of the fertilization and birth, a violin with musical notes, and so on. Will anyone receive these messages? Will we have an answer? But above all, what will those who receive this message be like?